In this video, we're going to finish our distance, rate, time, word problems worksheet on the KutaSoftware website. I'll leave a link in the description below so you know how to access this free Algebra 2 worksheet. Picking up where we left off, number 9. Jimmy drove to his cabin on the lake and back. So the distance there will be equal to the distance back. It took 0.6 hours longer to go there than it did to come back. The average speed on the trip there was 46 kilometers per hour. The average speed on the way back was 52 kilometers per hour. How many hours did the trip there take? Our variable is going to represent the number of hours it took to get there. So let's call this variable A. The average speed of the trip there was 46 kilometers per hour. So we're going to have 46 kilometers per hour times how many hours it took to get there, which is our variable A. That distance is going to be equal to the distance it took to go back. So the average speed of the trip back was 52 kilometers per hour. And it took 0.6 hours longer to go there, so that means the trip back was 0.6 hours shorter. So since our variable is how many hours it took to get there, we're going to take that variable A and we're going to subtract 0.6 hours because it was longer to get there than it was to come back, so we're subtracting that time from the trip back. Now let's go ahead and simplify. In all the previous problems, I've left my labels for speed, distance, and time in the equation, but now that you're familiar with that, I'm going to go ahead and drop them. But if you still feel the need to put the labels in, go ahead and do so. So 46 kilometers per hour times A is going to be 46A, and that's equal to 52 kilometers per hour times A minus 0.6. So I'm going to distribute this 52 to the A and to the 0.6 with subtraction in between. So I'm going to do 52A minus 52 times 0.6 will be 31.2. Next, I'm going to subtract 52A from both sides to move my variable to one side of the equation. 46A minus 52A is going to give me a negative 6A, and that's equal to negative 31.2. When I divide by negative 6, I'll get that A is equal to a positive 5.2. And remember, our variable represented hours, so this is 5.2 hours. So it took 5.2 hours for the trip there. In number 10, Anjali traveled to the recycling plant and back. The trip there took 5.8 hours and the trip back took 5.1. Since Anjali is going there and back, we know that that is the same distance. She averaged 7 miles per hour faster on the return trip than on the outbound trip. What was Anjali's average speed on the outbound trip? So we're looking for her average speed on the trip there. Let's make this variable X. So the trip there took 5.8 hours. So we have 5.8 hours. And we're going to multiply that by our unknown, which is the average speed of the trip there, X. That will give us the distance of the trip there. And we know that the distance there is the same as the distance back. So let's go ahead and calculate that. The trip back took 5.1 hours. We're going to multiply that by speed in order to get the distance back. She averaged 7 miles per hour faster on the return trip, so we're going to have to add 7 to X. So I'm going to be distributing 5.1 to the X and 5.1 to the 7 with addition in between. So I'll have 5.8X equal to 5.1X plus 5.1 times 7 is 35.7. Next, I'm going to subtract 5.1x from both sides. That's going to leave me with 0.7x, and that is equivalent to 35.7 because that's what I have left on the right. My last and final step is to divide by 0.7, and that's going to give me that my variable x is equal to 51, and the variable x represented speed, so that's 51 miles per hour. So 51 miles per hour is our solution in number 10. In number 11, a fishing boat left Hawaii traveling west 0.5 hours before a cruise ship. The cruise ship traveled in the opposite direction, going 12.5 kilometers per hour faster than the fishing boat, for a total of 11 hours, after which the ships were 322 kilometers apart. What was the fishing boat's speed? Let's go ahead and draw a diagram to help. I'll have my fishing boat going this way, I'll label that F, and the cruise ship will go that way, I'll label that C. My fishing boat left 0.5 hours before the cruise ship, and the cruise ship went a total of 11 hours. That means my fishing boat traveled a total of 11 plus 0.5 hours. And I'm going to multiply that by the fishing boat's speed, which is our unknown variable. Let's call this variable y. So speed times time is going to give me the distance of that fishing vessel. And I'm going to add that to the distance of the cruise ship. The cruise ship we know traveled for a total of 11 hours, and it traveled 12.5 kilometers per hour faster than the fishing boat. So we're going to multiply 11 by y plus 12.5. Since it's going faster, we're adding that 12.5. The distance the fishing boat traveled plus the distance the cruise ship traveled is going to equal the distance they are apart, which is 322 kilometers. So what I'm going to do is simplify, and I'm going to have to distribute this 11, and there's addition between those two terms. So 11 plus 0.5 is going to be 11.5. We're multiplying that to y, adding that to 11 times y, which gives us 11y, plus 11 times 12.5, which is 137.5, and that is all equal to 322. My next step, I'm going to combine the like terms on the left-hand side, and at the same time, I'm going to subtract 137.5 from both sides. 11.5y plus 11y is going to be 22.5y. 137.5 minus 137.5 is 0. So 0 plus 22.5y is 22.5y. And that's equal to 322 minus 137.5, which is 184.5. Next, I'll divide both sides by 22.5 to get y all by itself. That's going to give me that y is equal to 184.5 divided by 22.5, which is 8.2, and we're in terms of speed, so this is 8.2 kilometers per hour. And that's my solution for number 11. The last problem in this worksheet, number 12. However, before I go over the answer to this, as always, like this video and subscribe to my channel. Doing so encourages me to come out with more videos for you, so do that now if you haven't already. Number 12 states that a diesel train left the station traveling north 1.5 hours before a freight train. The freight train traveled in the opposite direction, going 6 kilometers per hour faster than that diesel train for a total of 2 hours, after which the trains were a total of 312.3 kilometers apart. And we're looking for the diesel train's speed. Let's call this variable x. So we have the diesel train traveling north and the freight trains traveling in the opposite direction, which would be south. The diesel train left the station 1.5 hours before the freight train, and the freight train traveled a total of 2 hours. So the diesel train traveled 1.5 hours plus 2 hours. And we're going to multiply that by the diesel train's speed to calculate the distance. And that speed is our unknown variable x. We're going to add that to the freight train's distance, which will be, again, time, which in our case is 2 hours, times speed, which is 6 kilometers per hour faster, so we're going to add 6 to our variable x. Adding those distances together will be equivalent to the distance they are apart, which is 312.3 kilometers. Now I'm going to simplify and solve. 1.5 plus 2 will give me 3.5, and that's multiplied by x, so 3.5x plus 2 times x, which is 2x, plus 2 times 6, which is 12, since we're distributing that 2 to the x and to the 6 with addition in between. That is all equal to 312.3. Now I'm going to combine my like terms on the left-hand side, which is my 3.5x and my 2x, and I'm also going to subtract 12 from both sides. 3.5x plus 2x is 5.5x. 12 minus 12 cancels out to be 0. 312.3 minus 12 is 300.3. Next, all I have to do is divide both sides by 5.5 to isolate that variable in order to find out what it's equal to. So I'll have x equal to 300.3 divided by 5.5, which is 54.6. And we're talking about the speed of the train, which will be kilometers per hour. 54.6 kilometers per hour is our final solution for the distance, rate, time, word problems worksheet. If you have any questions or need further clarification on any of the problems, please feel free to leave a comment below, and I'll respond to you as soon as I can. Also, like I said earlier in this video, don't forget to click that like button and subscribe to my channel.